All right, good morning, Algebra. I'm going to try to keep the same sort of style going that I usually have with teaching with all these videos. So basically, I'll introduce the problem, maybe give a hint, and then it's your job to pause the video, give it a try, and then I'll just sort of quickly show how it's done. It can be fast-forwarded if you need to, or if you're like, I can do this on my own, just skip the video for now and then just check the answers at the end. But really the video's there for you to use, for sure, but use it in your own way since you have the ability. All right, so let's start with the first one, sort of warm-up problem. Jaden received a gift of $180. In the first week, she spent a third of the gift money. She continues spending a third of what is left each week thereafter, which equation best represents the amount of gift money she has after 2 weeks. So at this point, pause it, see if you can figure out that question, and then come back and we'll talk about the answer. So if she spends a third of the money in the first day, and then continues to spend a third of what is left, that's exponential decay. We are losing 1/3 each week. So it's not going to be linear. And it's not going to be, well, that's it. Let's see. This one, the 180 is not the growth factor. That would be amazing for her money, but it's not. And let's see. So we're left between 2 and 4. And she spends a third of what's left. So really what remains of her money is 2/3. So we want to make sure that we cross off 2. But 2 is the best wrong answer there, but 4 is really the only one that matters. All right. Equations and the graphs. So a lot of today's lesson is going to focus on looking at models, like looking at the graphs versus the equations, comparing, contrasting, like which equation shows which graph shows which, and there's a big focus on graphs. So I know we don't have the ability to actually make graphs, so I've made a lot of them for you, but I will bring up a video later of how I'm making these graphs on the computer, because it's very easy and it can actually be very beneficial to you as well at home. So each of the following functions represents the amount of money in a bank account in dollars as a function of time, x in years. They are written in the form m of x equals a times b to the x power. So this is like our standard like formula where a represents our starting value or our y-intercept, and b represents our growth factor. All right, there's our 4 functions, f, g, h, and j. Label each line on the graph with the letter of the function that it represents. And one way, the step I decided to give you to help you out could be, first identify, well, they all start at 50. So after 1 year, how much is in each count? So figure out f of 1, g of 1, h of 1, j of 1 to help you make the graphs. So pause the video, give it a try. All right, so f of 1, let x be 1. 50 times 2 is 100. G of 1, 50 times 3 is 150. H of 1, 50 times 3 over 2, let's see, that's 150 over 2 is 75. And J of 1, 50 times a half is 25. So now I can also think, well, this graph is the only one that's decaying because all these numbers are bigger than 1. So J has to be this one down here that's decaying. And by the way, these graphs are all in full color if you open the task statements online, which you already know if you're following along with my handouts, you already know that the online ones are full color. And that graph is the purple one. That's purple graph. All right, let's see, f of 1 is 100. So after 1 year, the account's got $100, which is that middle graph right there. So that one's going to be F. G of 1 is at 150. So that means G of 1 has to be at 150, which is right here. So that's G of x, and that leaves this last one to be H of x. But also, I can think about this like, well, which growth factor is the highest? And of these 4 numbers, this one has the highest growth factor, which means that graph has to be the steepest increasing graph. So that's got to be there. Then I got medium increasing, and then I got my smallest growth factor of increasing. And then this one is my only one that's decreasing. So let's see, g of x was blue, h of x was green, and f of x is red. All right. And I'll also be posting answers to all this stuff tomorrow. Make sure you check the answers that I posted today for the previous day's activities. That way you make sure that you're not just floundering or making sure you're following along. Okay, next page. So again, same type of deal. All these equations are in the same form. Which graph goes where? So this is actually my favorite question here. I know they're both part A. I'm very sorry, just to be. Give that a try and see what you can make of question B. All right, so the value of A changes the graph. I've got 10 times 4 to the x, 40 times 4 to the x, and 100 times 4 to the x. So all it's changing is that first number. And that changes where the graph starts. On the y-axis. Because one that starts at 10 and is quadrupling, that one's got to start right there. So that one's got to be m. P starts at 40 and is quadrupling. And my last one's got to start at 100, so that one's got to be there. And if you look at these graphs, the equations all have the same growth factor. It is interesting. And if I look, it doesn't look like these lines, except going way over 0, it doesn't look like they'll ever sort of pass each other. One of them is not going to sort of overtake the other one and just sort of cross it at any point. And if I look kind of closely, I can see that the graphs all kind of form that same shape, especially starting at y equals 250. They're like that same shape. They're all going up at kind of the same angle. It's not like one's steeper than the rest. And even like way down here, if I start at like x equals 100 or y equals 100, they've all kind of got that same shape. And even if I went way off into the left, I know that they're never going to hit 0, and they're probably never going to cross each other either. And I could prove that to you, but it's not really important right now. So will these graphs ever intersect each other? The answer is no. But are they parallel? Parallel lines are lines that never intersect. But these aren't really lines, they're curves. And what about the equations indicates that they might indicate parallel growth? That would be the growth factor. They have the same growth factor. So they're kind of parallel in a way. Like parallel lines had the same slope. Like y equals 2x plus 1 and y equals 2x minus 5 had the same slope. They were parallel. So this is kind of the exponential function version of parallel. They have the same growth factor. So they are kind of parallel. Okay. Honestly, the next part of it you could probably do on your own, match each equation with the graph. So pause it, give it a try, then I'll come back and just show the right answers. Okay, so now that you've paused it, let's see. We got M, N, P, and Q. Highest growth factor means most of it's remaining, so it's got to be Q, P, N, and M. Decaying more quickly is f of x. Only 1/10 remains. So 9/10 leaves. All right. Feel free to email me with questions about all this stuff if you need it. A lot of this is stuff that you would be working with on your own at your tables. So it's stuff that we're not really going to talk about unless you have specific questions. Okay. What qualities make each function unique from the other three? This is more of like a thinking, like how are all these functions different from each other? So I'm not really going to talk about this question. This is just to get you thinking, like, all right, how are all of these things different? Think about growth factor. Think about slope. Think about exponential versus linear. Think about growth versus decay. All right? So, value of a computer. Here's a graph representing an exponential function. And again, another one, you can do this on your own. So pause it and do it on your own, and then check the answer when you're done. Now, if you're stuck on this one, I think I know why. Because 2 x's went by instead of just 1. So let's think about how we're going to solve this. So there's a couple different, there's one problem that comes here, and that's the problem is the fact that we have to use a growth factor once and then use it again to get there. So you have to find 400 times something gets me 100, and those something is the same thing. So 400 times some number squared gets me 100. So I'm solving for x, I can divide by 400. That's not really the scary part. And x squared is 1 over 4. Okay, so I don't know what times itself gets me 1/4, or maybe I do. But that's one thing we can think about, is what times itself gets me 1/4. So let's think about how to multiply fractions. Actually, no, I'll leave that for you. If you can figure that out, go for it. The other option I have is, well, let's see, x is 1 is like right here. And I'll just trace that up to my graph and see that after 1 year, I've got about $200 left on my value. And let's see how good that approximation was. What's my growth factor to get me from 400 to 200? It's a half. And okay, is that the same as 100 to 200? Yes. So my growth factor looks like it's about a half. So, is x equal to 1/2? Does 1/2 times 1/2 get me a quarter? See, 1 times 1 is 1, 2 times 2 is 4. So yes, in this case, my growth factor is 1/4. All right. So you can now continue pausing it and work on it on your own. All right, one strategy I'd say is pause the video to work. When you need help, resume it. And once you're like, oh, I know how to do this now, pause me again. All right, I'm not here to just drone at you. I'm here to be a resource for you. So pause it, keep working, and do through part F. So the next couple of questions, this one and the one on the next side, are more like critical thinking questions. So think about a function defined by f of x equals a times b to the x. It's a very helpful function, as you can tell. So if the graph goes through 210 and 830, would you expect f of 5 to be less than, equal to, or greater than 20? Let's think about where all these numbers came from. So we have a graph, and I'll just sketch it, because why not? I'll just count by, like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8. And over here, I'll just count by like 5. So like 5, 10, 15, 20, 25, 30. That's good enough. So 210 and 830. So my graph is exponential. So would I expect f of 5 right in the middle, 1, 2, 3, 4, 5, would that be more, equal to, or less than 20? And think about the shape of your graph. What shape is that graph going to have? Is it going to go up? Is it going to go straight? Or is it going to go down? It's going to go, as long as A and B are greater than 0, it's going to go like that. So it'll probably be less than 20. And let's think of the same thing on the back side. Same type of question. The next one. All right. So try to think about this one as well. They're not priority questions. They're just critical thinking questions to get you thinking. But the answer to this one you should arrive at is, pause if you want to figure it out. So you should arrive at the answer of less than. Because think about the same graph. Now it's at 2:30 and 8:10. And our typical graphs start up high and they go lower. So it's going to be less than 20, which is the halfway point between 30 and 10. It'll be way less than half. All right. And some more practice. Pause if you want to practice number 4. This you should be able to do no problem. Pause it. So there's your answers there. So there's your answers there. Growth factor, starting value, growth factor, starting value, f of 5 and f of 5. Last part of the lesson, moldy wall. Here are graphs representing two functions and descriptions. Match the descriptions. So really, function f doubling every month, function g is tripling every month. Which graph should be steeper? Tripling should be steeper, which means solid's got to be g and dash has got to be h. When it was first spotted and measured, was there more mold, A or B? Let's see, that would be, okay, so that's the tripling one. That's got less, so it's got more on the dashed line. The dashed line is H. Whatever H? It's F. Okay, F. Good job, Robideau. It's F. So, that one, which was mold A. So try to do part 7 on your own. What does the point PQ tell us in this situation? And this will be a flashback to our systems of equations unit. In the same month, P, so after 1 month, 2 months, 2.5, 3.25 months, there is the same area of mold, Q, inches squared. So remember we talked about systems of equations and the point where they intersect being where the same x and the same y are happening for both at the same time. It's the same type of deal here, where lines intersect, the same time has gone by, and the same output is being recorded. So, in the same month, there is the same area of mold. And just real quick, I want to show you, the last 2 pages are summaries, read through. It's nothing crazy new today, nothing really much different. A couple of different thinking questions we've had to deal with today, but nothing super crazy. And lesson B summary is again the same, just how to get stuff from the graph. All right, that's a lot of the big focus is going back and forth between the graphs of these functions and the equations and the situations. So make sure to do that exit slip. I'll post some practice problems and some answers the next day, and a cool down will probably just be the exit slip. All right. So, hope you enjoyed. Feel free to ask me any questions. I'll be here.